Hey guys, welcome back to Vedic Mathvantage. Last video, I taught you how to do cubes for numbers of 2 digits. Today, I'll be teaching you how we can find cube roots by just visualizing and observing. You might find this technique very similar to the square root technique that I have taught you a few videos ago. And that is true. In fact, this technique is far easier than the square root technique. Let's begin. Let me get a number, a small number, for example, 343. Now, according to the last video, you should have memorized all cubes from numbers 1 through 10, right? So if you observe this, automatically you can guess this is 7. So this part is fairly simple. Today's actual technique, I'll be teaching you how to find cube roots, for which the cube roots are 2-digit numbers. That means the cubes would be around 5 to 6 digits. Let's take a number 405224. Okay? Now you split the number down the middle, or actually you should start 3 digits from the rightmost and split it right there. Since it's a 6-digit number, you split it down the middle. We do the left part and right part separately, just like we did for the square roots. So we have 405. In the previous technique, we found the nearest square, which was smaller than this number. So here we find the nearest cube, which is smaller than this number. So 405, the nearest cube would be around 7 cube or maybe 8 cube. Now 8 cube, if you remember, is 512. So this is not possible. Take 7 cube, you have 343. So the left part of the answer is 7. That's it. And for the right part, in the square root, we would have to guess between two numbers. So for that we would find another number in between and check. Here on the other hand, you can see that it ends with 4. If I list down all the cubes, 1, 8, 7, basically 1, 8, then 27, then 64, 125, 216, 343, 512, 729, and of course 1000. Each of these digits are unique in the sense no two cubes share the same units digit. That makes our steps and the technique far easier. You can see the ending digit is 4 over here. That means we can choose this one, right? So cube root of 64 is just 4. So our final answer will be 74. And that's it. No additional steps required. Let me do this again for a different example. Okay? Let's say we have the number 140608. Split it down the middle, rather 3 steps from the right. You split it down. Left part of the answer ends with 0, but that doesn't matter. This is the left part, right? The smallest cube less than 140. If we take 4 cube, we have 64. Let's check with 5 cube, we have 125. That sounds about right, because 6 cube is just 216 and it's far too big. So our right part of the answer is 5. And that was the left part. And now for the right part, we just check with 8. If you remember correctly, 2 cubed is 8. So So automatically our answer will be 2. And there's our final answer. We have 140608. Cube root of that is just 52. And this is our answer. I hope you understood this technique, and the most important part of using this technique is that this technique can be used only and only for perfect cubes. If you take a random number 3, 5, 3, 6, 2, 9, it's very unlikely it's a perfect cube, first of all, and so this technique will not work whatsoever. In fact, you'll be far away from your answer. So try this technique only when you know that your answer is a perfect cube. I suppose this technique could work for decimals as well if you know that the decimal is placed in the right spot. Let me try something for decimals now. Now let's say we have a number 10.648. We need to find its cube root. Okay? What do? We split it, and when you have the decimal, you have to split it across wherever the decimal point is. And of course, this decimal itself will have to be 3 digits from the right. Otherwise, this number itself won't be a perfect cube. Okay? So we have 10.648. 10. Nearest cube less than 10 would be 2 cubed. 2 cubed is 8. So nearest cube we have nearest cube root is 2. Now you put the decimal point here. 648. Again, ends with 8, just like our previous question. That means our answer will be 2, because 2 cubed unit digit is 8. And this is our final answer. Here you have to be really careful with the decimal placement. If the number was 106.48 or 1.0648, it would not have been a perfect cube. Keep that in mind. If you know that the general number, in the sense here 10648, is a perfect cube, then the decimal point should be over here 3 digits from the right. Only then will this decimal number also be a perfect cube. Otherwise, you might find your number, you might get, let's say for 106.48, you'll have 2.2 into 2.2 into 22 rather than another 2.2. So your answer changes drastically. So keep in mind. And that's it for this video. See you again next time.